The other day, I showed you how you can use Desmos graphing calculator to solve this problem in few seconds. Today, I'm going to be showing you a step-by-step guide on how you can go through it if you're doing a written exam. And then the question simply says that we should find all the solutions in the interval 0 to 2 pi. Of course, 2 pi is not inclusive. For this trigonometric equation, cos 3x equals root 2 divided by 2. And let's get to it quickly. So this is the equation that we have. What this basically means is that we are solving for x, for values of x, for which this trig equation is true. The first thing we like to do here is to take the cos inverse of both sides, because the cos inverse will get rid of the cos, and whatever this is will be the principal argument of that of this particular trig equation. So when you do that, the cos inverse will get rid of the cos, so you have 3x left, and followed by, you also have cos inverse of root 2 divided by 2. Now, the cos inverse of root 2 divided by 2, if you look at your trigonometry ratios and then you look at your unit circle, there are actually two values that corresponds to a positive square root of 2 over 2. And those values are in your first quadrant and in your fourth quadrant. First quadrant and in your fourth quadrant. So the first value there is pi over 4, and the second value there is 7 pi over 4. So as you can see, I had already created a form of solution such that 3x, which is the cos inverse of root 2 over 2, is such that this can have two values in your from the range of 0 to 360 degrees. Now, we have pi over 4 and we have 7 pi over 4. This is in the first quadrant. This right here is in the first quadrant, and this is in the second quadrant. So if you don't know how to do that, you can check out the unit circle. You'll be able to see the value for this cos inverse. You'll be able to see it there, right there. Now, whenever you have gotten the solution of a quadrant of a trigonometric equation like this, the expected thing for you to do, especially if we are dealing with cosine and sine, is to add this periodic value in front of it, meaning that the value can continue to go on and on and on, because most trig functions are periodic in nature. That implies that for bigger angles, they tend to repeat the same values. And then that's this right here is 2k pi. That is what shows the repetition. So for every 2k pi, that is when you have moved around again, you come back to another bigger angle that will give this same result for the particular solution that we got here. So, and k is going from 0 to 1 to 2 to 3 and so on like that, depending on how many solutions that you want. Now, we have we want to solve this now just to make it a single fraction. So just find the LCM. Then that will be pi plus 8k pi, everything divided by 4. Then for the second one as well, we have 7 pi plus 8k pi, everything divided by 4. Then when we are done with that, what we are actually solving for is x. But so far, up to this point, I've solved for 3x. So it's time to get rid of the 3 and let x be isolated. And to do that, I'll have to divide both sides of the equations by 3. So dividing both sides of the equation by 3, that will just be multiplying each of these guys by 1 over 3. If I multiply this by 1 over 3, that will just affect the denominator, and that will become 12. And this one too will become 12. Add the numerator, they still remain, they retain their values. Don't forget k ranges from 0, 1, 2, and on like that. Now, we are almost done. The next thing we want to do now is that we want to substitute these values of k. When k is 0, when k is 1, when k is 2. We want to substitute that into each of these guys. So I'll be starting with the first one, which is pi plus 8k pi, all divided by 12. So when k is 0 and you substitute that in, you have these, then pi will be left up here. You have pi over 12. When k is 1, you have 8 multiplied by 1, that's 8 pi plus pi. That will be 9 pi over 12, and that will reduce to 3 pi over 4. Then you also have 8 times 2 pi, which is 16 pi plus pi. That would be 17 pi, all divided by 2. Now, how do you know when to stop? Because you have been given the range of the solution. We're told that we don't want the solution to exceed 2 pi. That is, values of x should not exceed 2 pi. So you would realize that from this place onward, where we have pi plus 8 times 3 pi all divided by 12, you realize that this is going to be a value that is above 2 pi. That's 8 times 3 is 24. 24 plus 1 is 25. So that's 25 pi over 12. That will be 2 point something. So we have gotten the 3 possible solutions for the first guy. Now we do the same thing for the second guy as well. That would be, we substitute k is 0, k is 1, k is 2, and k is what? K is 3. Then when you do all of that, you get 7 pi over 12, 5 pi over 4, 23 pi over 12. Of course, this last guy makes the value to exceed 2 pi. And then it seems like we are done with all the possible values that we can get. We have this and we have this. Then you can list all of these in increasing order, or you can just list them as you like. It will still be correct. So we have pi over 12 followed by 7 pi over 12, 3 pi over 4 followed by 5 pi over 4, and we have 17 pi over 12, and then we have 23 pi over 12. And that's how you solve problems like this.